Hey everybody, welcome to Tech Tree episode number 3. I'm joined as always by my co-host Sheban and Partha. Hello Sheban.
Hello listeners.
And hello Partha.
Hey Chirag, hey Sheban.
So in case you haven't checked it out, on our last episode we spoke about blockchain, explained to a 5-year-old with cake, and we also kind of wrapped up our smart homes discussion where we talked about ecosystems and some of the devices and some of the fun stuff you can do, so check it out if you haven't. So on this episode we're going to be talking about 3D printing and kind of talking about some of the things that are involved in getting started with 3D printing, especially if you live in Dubai or in this region. I'm going to get started by what is it really? I mean, we're using the word 3D printing, but what does it involve? Because it's not as simple as hitting the print button, right?
It is as simple as pressing print, but the technical term is not 3D printing. The technical term is additive manufacturing. 3D printing initially started with something called ABS, which is the most common form of plastic that's available. But then the problem with ABS is that because it's oil-based, there was a lot of fumes. It needed a lot more heat. So therefore, it wasn't really recommended for closed room or DIY or hobbyist level manufacturing or prototyping. 3D printing guys came up with an alternative using cornstarch called PLA, and this material is what is being used most commonly across all the different brands of 3D printers that are available commercially in the market today. So people from MakerBot to Ultimaker to you name those brands, they have a PLA machine. They also run a lot of different other materials, but we'll get to that shortly. The process of printing is essentially where there's an extruder, which is basically a heating element. This filament of PLA is being passed through it. It gets converted from a solid form, a filament, into liquid, and is then placed onto a build plate, and then a layer of PLA is then placed on the build plate, and then it's added one upon the other, therefore building the name additive manufacturing.
You mentioned additive manufacturing. Can you just throw in the explanation what subtractive manufacturing is?
So subtractive manufacturing is basically where you take a block of raw material and then you chip away at it till you get the desired output. So for example, if you look at wood carving as the most common form of subtractive manufacturing, you take a block of wood and then you create a lampshade or a canoe or a bed out of it. You're basically taking away material from the original source. That's what I refer to as subtractive.
So when you are going to Google up 3D printing, there's different things. There are 3 or 4 terms that will pop up. One is FDM, which stands for fused deposition modeling, which is the kind of 3D printing that you can, 3D printing tech that you can buy for your house. It's basically, like Partha has already explained, plastic that's being extruded out and put on layer by layer. The other one is SLS, which is laser sintering. So what it is they take a whole bunch of powder that's reactive to lasers, and then they use lasers to build a model layer by layer, again by burning the powder, which becomes solid. And then that's SLS. And then there's stereolithography, which is similar concept, but instead of powder, you have liquid resin. So when the laser hits the resin solidifies, and it basically you have this. And again, you go layer by layer, and you build upwards. What I will talk about is FDM or additive manufacturing, whatever you want to call it. But when you say 3D printing in general, most people are actually talking about the stuff that you buy for your house, the stuff that's within reach, because SLA and the other type are quite expensive. I mean, you're talking upwards of $10,000 probably per printer. And 3D printers right now we can have a good 3D printer for less than $1,000. The FDM plastic extruding models, right? Well, let's talk a bit about what exactly is it? How does it work? What it is these 3D printers, they take, imagine taking a piece of paper and taking a pen. And what you do is you draw a circle. And as soon as you've drawn the circle, now that ink is on that paper, and it's one layer. Imagine instead of ink, your pen is putting out a thin layer of plastic. Okay, so what you've done is then you've had a thin ring of plastic sitting on that paper. And imagine that paper is really, really sticky. So that plastic is now stuck. So if you want to turn that little ring and you want to add another layer to it, all you do is you draw above it. Now you have 2 rings, but these rings are a little bit thicker, right? And eventually, if you keep doing this, you end up with a cylinder. So that's kind of basically what 3D printing is. It's just layer by layer of putting molten material on top of each other in a very, very controlled manner. If you control the pen well enough, you can draw a perfect rectangle or a perfect square. And once you take these basic shapes, you can actually build more complex shapes and organic shapes.
Why is 3D printing important? What kind of convenience does it bring, compared to whatever the traditional model was? Partha, we'll start with you.
So we've been doing these workshops at the Assembly for a while. We've done about 5 or 6 different sessions. And every time we do a session on 3D printing, it's really full because people are curious as to how 3D printing can be used. The one thing that we've realized is that the most common application that we see are making toys, because when we show them how to design for 3D printing, they'll end up eventually making a toy, because that's the first thing that they can do. As far as applications are concerned, there are plenty. There's prototyping, so a manufacturer who has a hardware solution will use 3D printing to prototype. So it's to build scale models of architectural models, so interior designers, when they're trying to build, instead of relying on paper and craft and stuff, they can use a 3D printer to get far better detailing from the model that they are creating. Then of course there's spare parts manufacturing for automobiles and aircraft, and I think Sheban can actually talk about a lot more about that, because he's actually doing some more work around that.
Yes, I am. And so to expand a little bit on what Partha just said, 3D printing is one of those things when you introduce an industry or a bunch of people to it, and you think that, yeah, they're going to use it for this, this, and this. It turns out they're using it for that, plus 10 other things. So it's one of those things where people actually are finding more uses for it as the industry develops. And I think, again, it boils down to the fact that 3D printing wasn't accessible a few years ago. It was limited to very high-end industries that are doing rapid prototyping for very short runs or making master molds for things. So they had access to this kind of tech among other industries, of course. But suddenly now, with desktop 3D printers being available, it is quite literally, I mean, you can draw up a design on a basic CAD or download a design from these online repositories, press print. And while it's not as simple as pressing print and watching it come out, but yeah, it's getting pretty close to that point. And the uses for it are actually quite endless.
I'm going to add another bit ahead here. Is that 3D printing predominantly has been associated only with plastic, but obviously there are a ton of different materials that can be used in 3D printing, and that is definitely where you see the major variations of where they're being applied.
Where would be the benefit of doing this? Because when you talk about, say, architectural models and things, I mean, there were traditional ways of doing all of these things, right? I mean, in a workshop, when you say, like, okay, we're showing what we can do, and they're making toys with it. But these are, that's one aspect of it, right? Well, why is it that someone, an average person, an entrepreneur, someone that runs a business, like, why would he be interested in this? What direct benefit does he get outside of the fact that, okay, this is a different way to build a model?
So the why, I would say the why has three aspects to it. So A, if you're coming from industry, there's an aspect that sort of applies to you. B, if you're an entrepreneur or a DIY kind of person and you like making and tinkering with things, then this will apply to you. Or C, if you're a hobbyist, if you have a specific hobby, there are a lot of people that are into cosplay, there are a lot of people that are into building props and things like that. So this also applies to the craft and hobby sort of thing. So look at it as professional, semi-professional, and then hobby. Starting with professionals, and I think this sort of sums in the entrepreneur part, what you just mentioned. I can give you my example. So if I were to build a part for drones, I mean, I work in the drone industry, and where sometimes you have to make things that currently don't exist. So we designed it on CAD. Let's say it's a part for a drone, and it's supposed to be made out of metal or plastic or whatever. If I wanted to do it, the regular way was basically you go to a mold and die making shop or a machine shop, and then they will CNC the parts for you out of aluminum or out of whatever material you choose, wood, it doesn't matter. But the fact is that you would have to give them a CAD file, then they convert that CAD file into a machine file, and then blah, blah, blah. It's a long process. The average cost of making a mold can be close to 100,000 dirhams sometimes, depending on the kind of mold and how large it is. Sometimes it's more than that, sometimes a bit less than that. But again, it's expensive. Now, the other problem with this is, you spend all this money and you make a product or a prototype of a product, and then what's the next thing that's going to happen is you realize, oh, I should improve it this way and that way because you're going to test it. And then when the design changes, you got to go back and repeat the process all over again in some cases. So those costs really add up. 3D printing changes all of that, because what it means is you can rapidly print out a prototype. You don't have to go to a die shop or a mold shop or wait 3 weeks and then the CAD guy messes up and then you got to wait another week before the designs are finalized. None of that stuff. You can actually, through a small process of setting everything up, after that press print, and lo and behold, your creation comes to life. and you can see the results and then change it. So it really reduces that cycle that people used to go through. So for example, there's a lot of racing companies that are using 3D printing now to try and test different designs. For a semi-professional, if you're making small parts for maybe 10 run parts or 20 run parts, again, you don't have to go through that long process. You can just print it out and do a small production run, or you can actually print it out and then get a mold made. So it's a lot quicker either way. So you can test everything, make sure it's all final, and then you got your design done. Oof, you give it to the mold making guy. He makes a silicone mold out of it, and then you can cast things in it, and off you go. On the hobbyist side of things, I personally, I mean, again, speaking from local experience, I fly a lot of RC planes, and I like building models. So what I do now is I actually can improve my models. So if a part on a plane is broken, I can just design and print a better part. Or if I realize, I want to stick a camera on one of my aircraft to record footage, I can actually 3D print a camera mount. Or I can talk to other hobbyists across the world that are actually created parts for my kind of airplane, and then I can just download those parts. It actually saves me a lot of time. I don't always have to design stuff. I can just, download and print it off from somebody else's files. And so there's this little community of makers that have popped up over the last few years that are using 3D printing. And it's not just limited to this hobbyist thing. There are a lot of people that are building props from Lord of the Rings, or they want to. One really popular one that I saw the last time was from Game of Thrones, where they've got this hold the door, Hodor, doorstop, and you can print it out. You can just download it and print it out, and so now you have a little Hodor thing that you can slide under your door. So it really is a lot of creative stuff happening on this front.
One of the things that 3D printing does help is in saving cost via the use of material and accuracy. And I'm going to touch upon both of these things very, very briefly. So if you were to take the traditional mode of creating a spare part, using a piece of aluminium and milling out a cog, for example, the amount of material that you're actually wasting by milling that piece of aluminium is tremendous, because you'd probably end up using only about 40 to 50% of the actual aluminium to make the part, and the rest of it goes to waste. With 3D printing, because it's additive and not subtractive, you're literally using only the amount of material that is needed, which means that you're saving so much. So within that single block of metal that was wasted before, you could literally have two different parts. So you're doubling your the entire production value. That's one aspect of it. The second aspect of it is the accuracy point of things. Yes, there are tremendously gifted people, artisans out there who are able to create pieces that are beautiful and accurate, but then that's again quite rare. You will find that unless it is created using a computer or a CNC, again subtractive, so things like a water jet or things like that, again the wastage factor is one thing, but if it's being hand created, if there is a design that's being hand milled, the chances of the accuracy are, well, probably in the range of 70 to 80%. But when you 3D print something, the accuracy levels are about 95 to 98%, because you still have that little bit of leeway to fix things, and that's always going to happen. But again, the fact that you're not wasting as much material and you can actually test using different materials helps you save cost, and I think that is very crucial.
Okay, so I think from what both of you have said, I think one of the standout things is sort of the cost model is changing, right? And of course, there's also a time element, but again, the time element sort of starts wrapping itself back into cost when you're looking at least the industry and semi-professionals, but even for the hobbyists, right? Where you're saying now, instead of having this long delay cycle between figuring a design out, figuring something out, or even testing something, you can now reach a stage where it's sort of democratized. Like, so the individuals can start doing this at their level without having to wait for long lead times with factories and other places, running into issues, but also running into, what Sheban mentioned as well, right? Where you can do small 5 and 10 part runs as opposed to having to do a minimum 100 part run because you're dealing with a factory that has those kind of quantities. And so all of this kind of eventually adds back in both cost and time, being super efficient in getting this started. Okay, so my next question then is, so both of you mentioned this repeatedly, where you're talking about modeling. Okay, here's something that I want to design, and if I want to test it, or if I want to do a run, as we just mentioned, I'll 3D print it and get started. Is that all that can do, or can it do more than that? Because I know, Sheban, you've been also we were talking offline earlier about you sort of building other things using 3D printing, right? And so is this just meant to be a model and testing or is it also meant to be actually printing parts and things that can actually be used in production?
Yeah, so it's both. You can use one material to sort of test things out, and once you're happy with the results, you can use another material to actually build it all together. So in my case, to expand a bit on what you said, eventually the idea is to build a fixed-wing drone using 3D printing completely. There are already 3D printed aircraft around, but nothing on a hobby scale or a small scale. I mean, we're talking companies like Stratasys or very, very huge corporations. It's not easy to do. So there's a reason why I'm doing it, is because I'm like, okay, you know what? I have an idea in my head on how it is possible to put something like this together. And the idea also involves, it's also the concept that you can actually email parts electronically to people. So let's say I want to send parts of my drone to, I don't know, someplace in Africa. There's just been some sort of humanitarian disaster and they need help. So instead of shipping the drone, what you do is you email the files. They print it out at a local university or a local makerspace, and they put it together and off you go. You don't deal with customs, you don't deal with shipping, and also in disaster areas, logistics can be disrupted. So with this, all you need is access to the internet, and that's it. What I've been doing is I've been trying to model a fuselage for an airplane I used to have. I learned to fly on this plane, and it was very dear to me. All that's left of it now from all that crashing is just wings. And I said, all right, I'm going to one day build a plane around this wing. And so that's what I've been doing. I've been modeling different types of fuselages and trying to see if I can build something from scratch as opposed to downloading it off the internet. And it's been a huge learning curve, because you realize the amount of effort and thought that goes into designing product. Every single screw space, every single slope and bezel is being put in there purposely. It all has to tie in together perfectly for it to actually work. So I've been 3D printing the sections of this airplane. The idea is to just be able to print the outline of the fuselage and actually fill it with something, because plastic is quite heavy sometimes. A part is usually built hollow. So when you see a 3D printed part, it's not necessary that it's completely full of plastic. It's going to have something called infill inside it. And what that means is the printer actually creates a structure that holds the outside of the part up. Or you can make it completely solid, but it's just a waste of material. There's ways of sort of cleverly bridging certain gaps, and that's what we do. For me, the hobby part of it is that I'm going to take this plane out, I'm going to fly it, and then I'm going to improve on the design. And it's going to be an iterative process where I go out and I fly, and I'm like, I need to change the motor mount a little bit, so I'm going to change that. Oh, I need to change the placement of the electronics. I can do that. This wasn't possible before. For me to be able to have access to that is quite mind-boggling, because now I can tailor my aircraft to my needs as opposed to relying on some kit or a manufacturer to add that feature. I can just add it myself. And that is where the power of 3D printing really comes into play, because you don't really have to wait for anyone. Whatever you want to do, you can do. Is it something that anyone can do? No. You require some skills. I mean, I've learned CAD now, specific to 3D printing, so that I can actually build the models. So your mileage varies based on how far you want to take it.
So while I have experienced a lot of people using just for scale models, we've actually helped a couple of interior designers create a scale model replica of somebody's whole house, and it has served some purpose there as well. But we've also seen cases where materials like carbon fiber and Kevlar are being used to create high strength parts that are being used in machines, because these things have a very high resistance to heat and are actually very strong and very light. These are the ways that I'm actually seeing different materials being used. So I've seen people use metal to build spare parts as well. For example, I've seen gear levers for motorcycles being built 3D printed. You could go out there and buy something, but then those have been molded, and they cost a lot of money. Sometimes you want a different design. You can personalize the entire piece. So there are different ways that you can do this, but these are actual units, actual pieces that are being printed in materials that are very, very viable right now, and these are very easily accessible.
When we talk about modeling, that's one aspect, right? When we start talking about things that are in production value, and some of the stuff Partha has addressed, we have to start thinking about things like reliability. So now you're talking about an individual sitting at home buying a printer for less than $1,000 or whatever, maybe. But something that's within reach of the smaller companies and not necessarily the big factories, right? So how does reliability work for something where where you had a traditional model where you were taking a piece of like a block of metal, stripping it down, and it's still it's got its strength and its ability to work, and especially when we're talking about things like spare parts and all this other stuff. You talk about hundreds and thousands of materials and testing and the amount of quality control that goes into it. How does it? Is there a comparison? And is that why we still see like we're ramping up? We're going from modeling now slowly into production, because this is something where the modeling is the easy bit, but now we have to start thinking about all the quality control and everything that goes into it. So address the reliability point a little bit.
So from what I have seen, is 3D printing right now, it really depends on how much money you throw at it. So there are 3D printers that are worth hundreds of thousands of dollars, and the idea behind those is because the material has a high level of the material that the printer is going to be using. There's a lot of quality control that's gone into that, so that your filaments of a certain thickness, and it's not it's made by one manufacturer. It's like basically Apple giving you everything, right? Including the software and then the hardware and then the updates and all of that. When you scale it down from industry to small size, it doesn't necessarily scale all that well. It's really hard to explain economies of scale when it comes to 3D printing, because it's really, really useful for some people, and it's if you want to do like high quality, super tight production runs with extreme quality control, and you want every part to be an exact replica of the other part. Yeah, it is possible if you're building a basic shape, but not possible if you're building a complicated assembly of things, right? Like a machine that's got 100 parts. Well, you're going to run into problems with your $1,000 printer, and that's where the big guys come into play. Where when you buy from them and when you press the button, you know that what you're getting out of there, if it's 1/100th of an inch guaranteed, it's going to be pretty close to that. With what you get from the desktop models, they have to be tuned. You got to measure the diameter of the filament that you're using, because the manufacturer in China will label it as 3 millimeter, and then when you actually measure, it's like 2.85 or 2.84 or 3.2, and then you got to account for that. So it requires tinkering if you really, really want precision, and that is okay for some people. And the ones that are just putting out, let's say I'm making a statue. I don't really care if the nose is 3.2 millimeters or 5 millimeters, as long as it looks like a statue. Remember in the tabloids, you used to get those puzzles where you look at the two images and you try and see what's different. One of them is slightly different, and it's kind of hard to, it's like that if you're doing sort of organic structures. So again, if you're doing something that's functional, then yes, accuracy matters. And both have their challenges, Chirag. We could really sit down and talk about this all night, because even the aesthetic stuff, when you're building organic shapes, it's not that easy.
So Sheban touched on the reliability of the printing process, right? Which is perfect. So that's one angle of it. But then there's the other angle of it, which is the product itself.
So while Sheban actually talks about the process, and that's a very, very crucial point to remember, one of the things that you need to remember, also realize, is that 3D printing is essentially a scientific process that needs to have the same environment to create the same product over and over again. Think of it as a clean room that has to be maintained in order to produce something the same over and over again. The moment you're able to keep those factors in place and you 3D print something, you will create a product that is reliable over and over again.
So for me, the question is more, when we're talking about building like spare parts, we're talking about building, even Sheban was talking about building, say, his aircraft around his current, maybe an existing one, fuselages, whatever. There are critical components that we're talking about as well. So the hobby side, I think that's fine. I mean, as you mentioned, some of the organic designs, certain things, there might be a model, as you mentioned, toys and things like that, right? So that's one aspect of it. But when we're talking about things like spare parts and those kind of things where you're producing, and it's not just about the controlled environment, but it's also the reliability of the product, right? At the end of the day. So when you're building something that traditionally was built in a traditional format, where there was metal, where there was a different kind of plastic, doesn't matter. But then today, now you're taking a different material, there's a different process and all this. Is it something that that granted a little bit conceptually, we're already seeing conversations about things like a 3D printed building and 3D printed train carriages and all this other stuff, right? Which is great. I mean, it's good to envision, it's good to think at that scale and good to take the technology there. But are we actually building ourselves towards something that's really that reliable when we're talking about sort of this layer by layer printing and creating something versus what was traditional?
Brands are actually moving in that direction because there is a certain amount of reliability that comes into using this technology. Brands like Boeing are doing it. Oil and gas, you're seeing a lot of the machinery components are being built because they're offshore, and the fact that shipping to offshore rigs have taken so long, they're actually using 3D printed spare parts on their oil rigs. And this is obviously not because of the fact that it takes so long for the shipping, but because these things have proven to be reliable solutions for the long term, not only from a cost perspective but from an access perspective. There's an entire compliance thing that if the machine is not working to optimum speed, they will not be able to do anything, and if it affects manufacturing. So all of these factors come into play, and people are doing this around the world. So yes, it's definitely reliable, otherwise it's not something that is a viable solution for most companies to switch to.
Basically, a lot of the current 3D printing manufacturers, as far as reliability is concerned, this really directly addresses that. So some of the popular brands, there's Lulzbot, there is a very, very popular brand called the Prusa i3, which is, under $1,000 is one of the best printers you can get your hands on. I personally run on Lulzbot. Do you know what these guys do in their factories? They don't have people making the parts. They actually have other 3D printers, their own 3D printers. So you have Prusa i3, there's a bank of 400 of them running in a warehouse. They're all 3D printing parts that are then put together further down the assembly line that make even more 3D printers. Even if there are issues, I'm sure that people are checking some of these parts and doing an analysis to ensure that everything's within spec. Because you can just retune the machine and figure out let's say I'm printing a wheel, and the wheel's a little bit off. You go back to the machine, you tune it, off you go, and till it comes back within spec. So when you're talking extremely complicated things where you want to 3D print an entire airplane, like some people are saying, oh yeah, we're going to be doing this soon, where I believe it was Airbus or Boeing that said that they can use 3D printing to reduce the weight of their aircraft and increase fuel efficiency. Is that going to be reliable? Yeah, it will be, because, again, they're using composite materials. They've thought this through. It really boils down to how well engineered your solution is. And when I'm talking about engineering, I'm talking about both the parts and the machine that's putting the parts, making the parts. So
to use your example again, I completely understand the design part of it, right? So when you say that, hey, if this wheel is a little off, I'll redesign it, realign it, redo whatever it is in the process to make sure that this wheel runs smoothly, right? But my question is, can I put this wheel in a car and will it run as reliably as a regular tire would? That's my question.
Perfect. That's an amazing example, all right? So current tires are what? Made out of aluminum alloy, yes, which you have to cast. So you basically take the metal and you melt it, and then you put it in a cast, and out comes the wheel. With 3D printing, you could use a carbon steel structure, which you can 3D print. There are materials that allow you to do that. And you can print more complicated shapes than you could ever do in a cast mold. And it would still be as reliable, because at the end of it, what happens in a mold? It's molten metal, correct? That cools down and solidifies. The same thing happens in 3D printer. It's a molten material that's brought to its melting point, put there, and then it solidifies. I'll tell you this. Sometimes 3D printing is not the answer. Okay, so again, let's talk about what I know. Yesterday, I was having a discussion on the forums about there's an association of people. We call ourselves the 3D Lab Print Pilots Association, which is basically we print airplanes from a company called 3D Lab Print. And the idea is you can take a World War II prop fighter like a P-51 Mustang or a Messerschmitt or something like that, and print it out for yourself. So you don't have to go out buy a model. You can print it out on your home desktop printer in different small little parts and then glue it together. It is so complicated that sometimes when you're doing it, you see people are frustrated online on Facebook because they're expecting one result and they're getting something else. There's like holes in it, or there's strings where the plastic's not melted, or it's too hot and it's melted too much and it's failing structurally because it's falling in on itself, or it's turning into spaghetti. And when they finally do print these planes, and they look gorgeous, and they look beautiful because they're designed from very detailed plans, they don't necessarily fly that well. It's not like you've suddenly revolutionized RC flying by printing this thing. No. These things are heavy. These things are brittle. And these things are sensitive to UV light. So when you're flying them in the sun or you leave them in a hot car, they can melt. Is it more practical? Of course not. It hasn't replaced a traditional RC airplane. What it has done is it's shown people that there's another way of getting something flying and possibly doing it in your house. And if you break apart, you can reprint it. Or if there's a new material down the line, for example, right now everyone's using plastic, but let's say tomorrow there's some super reinforced plastic, which are actually already coming to the market, which is stronger than regular foam and regular wood, balsa wood that's used in plane design. Maybe you'll switch over to that and you just reprint your parts in a new material and off you go. You have a stronger, lighter, faster airplane. When I got started with 3D printing, I just thought it would be super simple. I'm just going to download a shape. I'm going to hit print, and out will come this perfectly working, amazing structural thing, and it's all going to be, peaches and cream. That's not how it really works. If you're getting even the best 3D printer on the market right now for consumers, it's if you're doing simple stuff like squares and circles, yeah, it's fine. But if you want to build something a bit more complicated, it will require you to tinker with it. It will require you to tune your printer, to keep it tuned, and to basically start small. So you will start printing with squares and measuring them, making sure that they're the right dimensions, and then you will work your way up to more complex structures. The first time I saw 3D, I remember very clearly, I had a requirement for a casing. It was not a casing for a drone, but it's basically for the flight controller, which is this electronic thing. And it was a prototype board. There was no casing for it on the market because the manufacturer didn't make one. So I went up to Partha and I was like, dude, I know you guys have access to 3D printing. Can you, make me this part? And I downloaded a casing that somebody else had made in Spain. He went away and he gave that part to one of his minions, and back came this little fuzzy little thing, and it fit, it worked. So Partha, I want to ask you, how did you get started in 3D printing? And I've been talking about how complicated these things can be, and I've seen at the assembly you guys print some pretty complex projects. What is the most challenging project you've printed to date?
Okay, so I started off with 3D printing about 3-something years ago when we got the MakerBot Gen 5. About 3 years, and we've been doing we started off with building basic rover cases and Raspberry Pi cases and mobile phone covers, the usual stuff. Then we started actually designing rovers. By rovers, I mean, we're teaching people how to build robotics, right? So we've done stuff like robotic snakes, where they have multiple different moving parts and they have to be connected with servo motors. We've built a precision robotic arm with 3D printing. But the most complicated thing would have to be the Qualcomm rover. And the Qualcomm rover is essentially designed in such a way to show the use of mobile technology, the fusion of mobile technology with 3D printing, with robotics, and to show how Snapdragon could actually power robotics. And 3D printing being open source, they could just release the designs online and you could do a lot of different fun stuff with it. Now the thing is, the reason it's complicated is because that had about 20 moving parts, but about 45 different pieces that had to be printed, cleaned, and then assembled in association with adding electronics to it. And I think that by far has been my most complex project till date. It was a learning curve for me. I must have wasted about 2 or 3. I had to do two or three different reprints the first time, and then eventually we just got better at it, and we ended up making 3 rovers that work beautifully. And we actually showcased it at ArabNet, and it was amazing. There's another thing that we made, which was essentially, and this was crowdsourced, and this was basically a small little robot figurine, but with moving parts without any assembly. This is the ingenuity of 3D printing, is that you could actually do something like that. And when we show it off to people, they're like, no way that was printed in one go. But it was. And this is how useful 3D printing can be. There's so much possible. So we've done robots and stuff as well. So we have one little dancing robot in the lab that's called Blue. And he basically is 3D printed, and we've added motors and everything to it, and that's what we do. We show people how to do stuff like this, and it gives people an idea of how to work with robotics. It gives people an idea of how to create designs on 3D printing, on 3D design software that are actually open source and available, and it's not that difficult to get into it. And a lot of people associate a lot of technical knowledge to go into 3D design and printing. It's actually very logical and far less intimidating when you actually jump into it.
It depends on like what you said. You're right. Yes, you're right. If you want to do basic things, yes. But if you want to build like a complex robot from scratch, which has, I don't know, like articulating hands and things like that, don't you think it would take a lot of, like, I remember simple things like getting two parts to fit. You would think, oh, I'm going to make this thing 20 millimeters. I'm going to make the other thing 19 millimeters and it's going to fit. And no, well, it's not going to fit. It's going to be loose because apparently there's something called friction fit, and you have to learn about that because the tolerance between the two parts has to be a certain 15th of a millimeter or something crazy like that. And then it will press fit. So that's what I mean when I was saying earlier that it can get a little complicated. Again, it depends on what your needs are and if you want and how far you want to take it.
You and I learned that through trial and error. So when we conduct our workshops, we actually show people and explain to people that that's fairly logical. I mean, when you share that logic with people and you share that information, it's not technical per se. It's just, something that you learn because we've tried it. I'm not an engineer. I know you are, and when we share information with people on about this in our workshops, we tell them that this is what we did, this is the outcome. What you need to do is remember this, and when you design it, you will obviously realize that it's easier for you to build something by keeping these little things in mind. And yeah, it helps. So a lot more people are getting into 3D design, and there are a ton of tools and a ton of tutorials available online to actually show people how to build stuff.
Okay, now let's move on to, like, getting into 3D printing is sort of, there's a whole scale of things you can do, right? If I were to want to get started in it, so how does one go about it?
So first you got to figure out whether 3D printing, I wouldn't say whether it's right for you, but first figure out, let's say you take the plunge, a lot of people I see that have bought 3D printers, what they're still doing? They're still printing squares and circles. So you really need to know whether you really need it. And let's say you're a maker and you're actually designing things or you want to download things off the internet that you want to print for yourself, or it's just something really cool and you want it. Yes, absolutely, go for it. I mean, you can get a 3D printer for less than $500 now, which will produce reasonably good prints with a reasonably small amount of headache. So is it accessible? Absolutely, yes. Is it exciting? Yes, it is worth, if you're a tinkerer, it's absolutely worth exploring, because also you will learn a lot, and it's a lot of fun for a person to make something on a screen and then actually have it materialize. I mean, that used to be the kind of things we used to read about in science fiction books, and we can actually make that happen, right? You got to look at how big you want your objects to be. So that's the first consideration. If you're happy with the, printer's build, we call it build volume. So that's your first consideration. You're like, okay, I want to print big things. So let's say you're into cosplay and you want to print Thor's hammer. Now, Thor's hammer is generally quite big. It's something if you're gonna take to an exhibition or to a show, you're looking at something that's about the size of a small dog. The average 3D printer, like the one I have, for example, will not be able to print that. It would, but you'd have to print it in small, tiny parts and then glue it all together, which is a very time-consuming and arduous process. So what you should do then is get a printer with a larger build volume. The other thing is also, are you technical? If you're a technical tinkerer, there are certain models that are going to be more appealing to you. But if you're the kind of person who really does not want to mess with code and does not want to, go on forums and figure out, why is my print doing this, or why is my printer doing that, then please, by all means, go with something like Partha's using. These guys have very automated machines, which the manufacturers have really done the thinking for you guys. And the reason they're using it, of course, is because they're putting stuff out for workshops. They don't want to be spending time tinkering with the code. So get an Ultimaker or a MakerBot, or there's other printers in the market. If you're DIY kind of person, your budget is less than $1,000. Some of the best printers you can get for the money right now. Look at the Prusa i3 Mark II or 3. There's a huge waiting list on them because there's an insane amount of people that want to get their hands on them. So be prepared to wait for at least 2 or 3 months before it shows up. There's also the Ultimakers, which are also good printers for less than $1,000. Look at the Lulzbots. There's the Taz 5. There's something called the Lulzbot Mini. Going to the Chinese brand, there's something called the ANET A8. There's the Creality CR10. The CR10 and the A8, they have pretty large build volumes, so you can get started with that. Above $1,000.
So the CR10 is basically a 2.5 cubic centimeter of build volume for 4,300, I think is about in the market. But you can get a 3D printer in the market for about 1,300 dirhams, by the way. It's easily available. Any Cubic is the brand, Kossel. And these are DIY machines that you can actually put together. And by the way, it does a lot of the 3D printing, the leveling, and all of it by itself. So it's a good machine to start. I mean, if you're really want to get into 3D printing, these are great machines to go into.
Yeah. And the last one, this list would not be complete without mentioning another company, which is Monoprice. They don't always make the best printers. I mean, you got to do a little bit of research, but they also have decent printers, like the Monoprice Select Mini or whichever the latest version is. They're usually, again, less than $500 mark. Above $1,000, there's a lot more options. Ultimakers are actually better. If you want push button stuff, look at the Lulzbot Taz 5s. They're, I think, upwards of $1,000, and then the Ultimakers are also upwards of $1,000.
Bots also are in that same range, and actually the new smaller machines are pretty decent, so they're also upwards of 1,000. They're pretty slick desktop machines.
Yeah, and as far as materials are concerned, that's your next big thing. There's 3 or 4 kinds of materials that you will use in your 3D printing life. There's PLA, like Partha has already said. There's ABS, there's nylon, there's also flexible filaments. PLA, the reason people prefer it to use it, it's non-toxic and it's, all of that, but also it's easy to print. So you could have a really super basic printer with no heated bed, and a PLA will work on it because it's got a low melting point, so you don't have to have your hot end, which is this bit which extrudes all this mold. This is responsible for melting all that plastic. It doesn't necessarily have to go to a very high temperature to melt PLA. ABS is very, very tough. It's usually used when you want something that's going to be super durable. You want to knock it around without it breaking, then you go with ABS. But be prepared. You've got to have a space that's sort of ventilated. Do not expect to put your 3D printer in your bedroom or in your living room or in your office printing ABS. It produces noxious fumes. So you've got to be mindful of that, especially if you have pets or kids. Or yourself, of course. Never discount yourself, please. Be a little selfish. There's high impact polystyrene, which is HIPS. HIPS is similar to the kind of material you find in bottles. And these are the 3 or 4 materials that you will actually play with. There's Ninja Flex, which is new because it's flexible material that you can print with. I wouldn't say it's a beginner material, but if you want to print things that flex around or bounce, that's something to look at. Concentrate more on your needs. Start small because eventually what's going to happen is you will upgrade your printer after you grow out of it. So if you know that you're just going to learn, pick something basic and then upgrade. If you want to really learn, build it yourself. Get a kit printer. You will spend about 12 hours on average putting it together. But that'll be a 12-hour learning experience. So be prepared for some frustration, but you'll know a lot more about how 3D printers work if you do that.
So let's talk a little bit about let's see if you guys can summarize for me the local scene. So obviously, like all the stuff that Sheban you mentioned and stuff, in addition to people can Google it, we'll leave some links in the show notes to directing them to these different websites. What about accessibility here? Is it easy to pick up 3D printers here? I know you guys you do work where you do ship things in and stuff like that. But for someone that's a beginner, what's the scene here?
Printers, actually, there are a ton of different companies that have bought 3D printers into here. 2 of the bigger groups that have actually done this, one is Techies and one is Precise. Precise have actually consumerized 3D printing really well. They've actually bought in a couple different range of brands. So they have Ultimaker and they have 3Doodler. 3Doodler is basically the hand extrusion pen for creative types, and Ultimaker are basically aimed at consumer desktop 3D printing. They also have a whole bunch of other stuff that they can do, and they have services as well. These are the 2 big companies that are doing it. But then there are also smaller companies. I was recently introduced to a couple of Lebanese guys who are bringing in a ton of different American and Chinese brands, and they'll come into the picture very soon. They're bringing the Cosel, they're bringing the CR10, and they're bringing Anycubic and all of these other different brands into the region. If you don't have a 3D printer, and I highly recommend that you don't jump in and buy a 3D printer until you know what you want to get out of it. There are companies like Immensa that do 3D printing services, whether you have a 3D printer or not. So you have a whole different wide range of services available. If you want to get into 3D design, the assembly, we do workshops quite regularly on how 3D design works. We actually explain the entire process of how 3D printing works, what you need to remember, how you need to learn design and use the tips and tricks for your future project. And we get a nice varied range of people who come in and actually thank us. I mean, we're doing a whole bunch of university outreach around 3D printing and robotics happening later this month.
So that's a very good point Partha brings up. if you really do want to get started in 3D printers before dropping a whole bunch of cash on it, there are actually quite a few maker spaces. So I've been to one of the assemblies, quite a few of the assemblies workshops. You can go down there and have a look at what it looks like, how it works, what a part looks like. So once you actually see the parts, you realize, this is for me. Yes, this works. Or you'd be like, nah, that's not how I thought it would be. This is not for me. Maybe I'll wait till things change, or maybe I'll look into other options. There's also like Astro Labs, I think in Dubai. They have a makerspace. If you Google makerspaces, there's quite a few of them that have recently opened, where you can basically get a membership or go on a one-time pay basis and get access to CNC and soldering stations and printers and plotters and cutters and laser engravers and all of that fun stuff. And that way you get to try it out without actually, putting down a whole bunch of money, and you can decide for yourself whether it's for you.
Yeah, I think that's an awesome point, actually, because I think that's really that probably should be the way to go about it. If you're a beginner, you've sort of figured out all these basic steps, right? You figured out whether you want to get involved with somebody or you want to buy your own 3D printer and stuff. What are some of the things to watch out for, when you're starting a project?
So, assuming you've already got your own 3D printer and you've set it up in your own room and you want to start building your own project, top 2-3 things that I would suggest that you need to keep in mind are: one, ensure that your design works 100% through virtualization. I mean, you need to be able to visualize the project and make sure that your design is complete. The settings that you're using, if you're using a consumer device like a MakerBot or something, they have a ton of different specifications within the printing software that help you customize and make the actual prototype to your liking. So make sure that you check every setting. No setting is unimportant. Every setting is definitely important for you to know what is going into making this prototype for you, this model for you. And the third thing that I would think is very crucial is where you set up the machine. You need to ensure that the entire environment around the machine is suitable for the machine to work at its optimum capability, in the sense that you don't have the AC too cold or too warm. There's enough ventilation, there's enough airflow, you have enough light. Make sure you have the right kind of all of these different things are very crucial to making sure that you get the right reliable print coming out of that machine and you're getting the best quality. These are just few things that I think are important.
All right, so from my side, I'm going to get a little bit more technical. Top beginner mistakes are, so let's say you're printing with a certain material and you use settings for the other material. So let's say you're printing with PLA and your temperature for printing is set for ABS or nylon or some other material. You're going to find your print comes out and it looks like a lot of goop. So because you're printing it too hot. So I'm going to link in the show notes a very handy guide, which has really, really helped me in my 3D printing journey. It's from a company called Simplified 3D. They basically create slicing software. Now, when you actually are printing using whatever printer, what that does, one thing we haven't touched off during the show is the software. It's really, really important to talk about it. There's 3 or 4 major slicing software in the market right now. There's something called Slicer, which has been around for a long time. There's something called Cura, which has been around for a lesser amount of time, but it's now really gaining in popularity. There's also something called Simplified 3D. There are a couple others, but these 3 are the most popular ones. The first 2 are free. Simplified 3D is actually paid. I think it's $200 or something like that. So it's not cheap, $100 or $200. But it is very, very customizable, and a lot of people use that for that reason. You can really fine tune the settings on that and get under the hood. What is a slicer? All right. So when you are printing a simple cube and you press print, what it does is it actually takes the actual CAD file, it sends it to the slicer, which basically then slices up that object into hundreds of different layers. And then it says, all right, this layer is going to be this thick and I'm going to print it. And 800 layers are going to make an 8 cm object or a 8 millimeter object rather. And that's kind of how it works. So it slices. The slicing program is really important. Your top problems will be too much materials coming out of your nozzle, too little material, or your printer is not calibrated properly. That's really, really important. You have to calibrate your printer. Check with the manufacturer on what the right calibration guides are. Don't expect to press print on a newly assembled printer and have it work flawlessly. usually doesn't always work that way unless it's factory assembled. And even then, get familiar with these slicing software. Like Partha said, even changes in environment can change your print settings, basically. So if it's cold outside, you may want to print a little warmer. If it's warm or a little too humid, these things really, really come into play. So the top 3 or 4 problems you will encounter is over extrusion or under extrusion. You will see something called layer shift, which is when your motors on your printer are not really in sync, so it's not all printing in one axis, and the layers are sort of shifting. It's like we used the cake example, except now the layers are shifting, so the cake is a bit lopsided. Or you'll see artifacts on the skin of your print. That's also caused by various issues. Warping can usually be probably because of overheating, actually, like I said a little earlier. The part is hot when it's being printed, and as it's cooling, it starts to shrink. And if it shrinks at different rates, it will warp. So this is a problem that Partha talked about earlier. This happens a lot with ABS. So ABS is quite challenging. You have to actually have an enclosure around it. These are things you will pick up as you progress in your 3D printing journey. It's important to just not get frustrated, keep to the basics, print small parts that you can really control. So once you're happy with those small parts, take on the larger projects. That's really, really important. Print calibration cubes and test all your settings out on that. Make sure it's working for your brand of filament and your brand of printer and your brand of nozzle. And after that, move on to more complex projects.
Awesome. Thank you, guys. That was, I think, a lot of information in there. As I mentioned already, we will link to a bunch of things in the show notes for people who want to click on, read on more about it. As always, Sheban, if you can share your Twitter handle so that people can harass you about 3D printing.
So if you want to harass me about 3D printing, you can reach me on @airspective. That's AIRSPECTIV. You'll see that also in the show notes. Look me up if you've got any problems. Like I said, I'm not an expert in this, but I'm enough to sort of make and engineer my own parts right now. But I can always try and help people if and do some research if required.
And Partha, if you can give us your, to reach you as well, and maybe also tell us how people can look up, your workshops on 3D printing.
I am reachable as Partha NS, PARTHANS on Twitter, and the workshops that I run are under the brand called The Assembly. To sign up, it's free. Our memberships, our community is basically free access to everybody, and we conduct workshops every Saturday. Visit members.techies.ae. Join us for any of the workshops that are coming up, and we'll be happy to address all your questions for 3D printing.
Well, we'll link to that in the show notes as well. I'm reachable on Twitter at ChiragND, so that's CHIRAGND. Man, I can't do it as musically as Sheban, and you guys can, but okay. So that's it from us for this episode. Join us next time. Until then, it's goodbye.